Alright, physics video. Hey, I'm one in the theoria impossilopolis. So everything he says is impossible. But anyway, so it's a really short video, so I guess I could talk about some other stuff related to the last few videos. The last one on the light and glass was sort of interesting because, I was thinking about water, and it's so fluid. But also when you freeze water, you see that it is crystals. And, that somehow when water's moving, a bunch of different speeds, you would imagine the flow of water would have lots of pieces of water moving at different rates. And that somehow they mesh with each other perfectly consistently, in that no matter what angle, like if I have water in a clear tube, I can see through the water. It wouldn't matter which way I looked through the water, I could see what was on the other side, barring the problem of the round surface. So if you have to kind of make it square or something, I suppose, to fix that. But it does raise an interesting question about photons actually having to travel through something moving, and whether you could ever move it fast enough to actually distort the image, where you would start to cause a breakdown in whatever the mechanism is that subtly moves the photon through the medium. But anyway, it's something worth thinking about. I have to do some thoughts on. See, I just don't want to get into chemistry, because I think it's sort of a chemistry thing in the end. It really depends on how the electrons and protons of the molecules are arranged. And especially with water, it's a good example in the sense that water's very sticky to water. I mean, not necessarily very sticky to us, but you can't really help getting water on you. If you stick your finger in water, it's going to stick to you. So it does stick to the water in our hands, in our surface of our body. So it is very sticky, to itself. The little pieces stick to each other very well. No, it's just, it gets, that stuff. I mean, blending chemistry and physics would be a nice thing to do once I get this physics thing done. It's moving it into the chemistry thing, because, the chemistry of diamonds versus soot is very, it's kind of an amazing difference. And anyway, this idea of the moving medium, still transmitting light, is interesting. Well, anyway, now to something less interesting. But it's only 3 minutes, which is great, and it has definitions in it, so this should be helpful in some respects.
I don't know, how much you know about electricity in general or specific or electrical theory, but everybody...
I don't think you know anything about it, which is really interesting, because he's such a whore for Tesla. And what he's going to talk about, counter space and ground, especially the ground part, that's all Tesla, and so he should have this stuff right, not wrong. He should have it much righter.
Keeps wanting me to define counter space, and of course that's just...
Oh, poo.
We're Rhett and Link, and we wanted to show you how we created our amazing new website with Wix. Now, we know that having a great website is...
Pathetic word.
Is it like men afraid of women things or something? What are those guys? Weird and weirder. Weirdest. Anyway, okay. Maybe I'll put the I'll cut the speed down to normal. It's only 3 minutes. I should be able to do normal.
It sounds kind of silly. You could say...
Yes, counter space sounds kind of silly. So I will write down counter space. So now we're going to get to know what it is. Dun, dun, dun. You're not going to believe this when you hear it.
Anti-space, I mean...
Okay, we could call it anti-space. So that equals anti-space. Okay, so we'll keep that in mind. So when you say anti-space, I'll know what you're talking about. Counter space.
Actually, space and magnetism and force and motion.
Okay, space and magnetism. Okay, S-P-A-C-E. And mag. And force in motion. Okay, so space, magnetism, force in motion.
And centrifugal divergence.
And centrifugal divergence. Fugal divergence. Okay, so space, magnetism, force in motion, and centrifugal divergence are...
all refer to one and the same thing, the loss of inertia.
Loss of inertia. Okay, so we got that one. So equals loss of inertia. Yeah. All right, now we're moving right along. So this is very good. Vocabulary is good. It's good to make sure we have the same vocabulary.
But not inertia in the conventional sense that you...
Oh, damn. I only had the conventional sense. I didn't know I was supposed to have all the other senses. Some people name their turtle, inertia. I'm sure there's a turtle somewhere on Earth named Inertia. You had a turtle in the video. I should have watched that one. I love turtles. Yeah.
You think of a car having forward momentum and inertia. We're talking about the original denotation.
Okay, so the regular denotation, which is another word for equal sign, I suppose. Anyway, so the regular denotation, I'm not going to write that down. Denotation means definition, I think.
Inertia, which would be pure potential.
Pure potential. Okay, so that one I can understand, unless pure isn't pure. But what is potential? Potential what? P-O-T-E-N-T-I-A-L. So loss of inertia equals being purely potentially, and that's what space, magnetism, force in motion, and centrifugal divergence all are, is pure potential. But the thing is, how can it be pure? I mean, it all comes in volumes. Well, we'll see.
People think of everything ass backwards. Since humanity is stupid, we think...
Okay, so we're all stupid because we didn't know there was the real definition of inertia. The real denotation from denotatia is pure potential. Dun, 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 dun. So we're all assholes and idiots.
Think of power.
Power is not a good word. So yes, that's like love. That's a very dangerous word. So power usually refers to you having to do something. So that's my definition. Something has to do something. If something doesn't do something, no power. But if you have to do something, like if you have to, the battery's here and you want the battery to be here, well, somewhere you have to, something has to power it. It has to be powered there.
In backwards terms, like if you see a nuclear explosion, it's like, wow, there's an enormous amount of power. No, that's the loss of power.
Right, so I would agree in the sense that obviously if the gas tank blows up, you don't have a whole bunch of more gas. You just lost your gas is gone. So it's sort of the loss of fuel, maybe you could say. Maybe power could be fuel. Maybe, I'll put a little maybe equal sign and say maybe fuel. But I think the real key word he's looking for in all this mush is the word pressure. See? So he uses words like, what does he use for the contraction? He uses some other silly word in expansion. But that's really what he's talking about here. So the pressure, the potential to blow up, exist in the gasoline or in the nuclear bomb, and so that's a way of understanding what he's saying, which isn't irrational. That would be rational to just say that where compression exists, not a rarefaction. So he uses compression and rarefaction instead of compression and expansion. So the nuclear bomb would be the expansion of the energetic bits, and the nuclear bomb before it blows up would be the compression of the little bits. So we could agree if that might be agreeable.
True power, true potential, analogously would be, that shiny lump plutonium that's just sitting there. It's like, wow, that is true power. It's like, nah, it's just a little ball. It's like, nah, that's enough to level an entire city. That's
Yeah, but see, actually, obviously, you know, you could go by atomic weight and say, well, I have one little round ball of plutonium, or, you know, I have a big, giant pile of gold. Now, which one has more energy? Well, the argument is the big, giant pile of gold would weigh more and there'd be more potential in it. So you can't get, you know, fooled by shiny or even density. Well, density is important. I mean, volume. Can't be fooled. You have to understand that each atom has that capacity. And the only reason why the plutonium is interesting, or the uranium, is because it's in a condition that's easy to uncompress. So plutonium's easy to uncompress, but theoretically an equal amount, mass-wise, of gold is just as much potential, quote unquote, just as much compression, just as much fuel, theoretically, just isn't as easy to get it to ignite. Water doesn't catch fire very easy, but you see, technically there's lots of potential for it to burn, just you can't seem to create enough heat and pressure to get it started.
It's the actual power, not the release of power. But what about an electron?
Okay, not the release of power. Well, I think the release of power should be, you know, it's pretty significant in terms of there's no power until it is released, but okay. Pure potential and potential and pressure should be words. They both start with a P. U-R-E. This is going somewhere, by the way. So potential and pressure are really good words when you start talking about electricity. Yeah. So you're heading in the right direction. You just don't know it.
Electrical ground. What do you, in all electrical circuits, what did you think a ground was?
I thought it was the average pressure. See, that's what I thought it was. So it's the idea that there's there can be high pressure and there can be low pressure. That is, there can be plus voltage and there can be minus voltage. And what it's plus and minus to is an average amount. So a ground isn't no pressure. A ground is the average pressure of all the matter around the thing you're grounded to. So it's the average pressure. And if you go lower, then you have a minus voltage. That is, it's hungry for electrons. And if you go above, then you have a excess of electrons. Obviously, it's the other way around, but we don't worry about that because, you know, Benjamin Franklin, so we made a little mistake. It's no big deal. Sort of is a big deal. They should have fixed it. Like the metric system, the U.S. should have really said, okay, yes, it wasn't working too well. We couldn't get people to go along, but there was no point in giving up. They should have just said, well, another 10 years. It'll just take another 10 years, that's all. But it's something they should have done, and they should have fixed this whole electrical thing.
You know, ground is counter space.
Okay, so now ground is potential and pressure. It's the loss of inertia. It's space. It's magnetism, force in motion, and centrifugal divergence. Okay, well anyway, let's just deal with the point that it can't be any of these pure things. So, because it's an average. So averages are by definition not pure. So ground can't be pure potential. So, you know, you're leading your little minions astray here with this kind of mush.
Ground is the ether.
Ground is, okay, so now it's the ether too. Alright, so when the potential, well, I guess we just have an equal sign. So space equals the ether. Right? Or you have to make the space ground. Well, first you take the space Well, it already lost its inertia. Then it became pure potential, and which is essentially the same as full of pressure, which equals the ether. So that would make sense. So if I take that route and said ether equals pressure, well, now we're starting to get somewhere, because I can relate to that. But I would just do away with the ether thing. It's just a silly notion. Just stick with the pressure part. Space equals pressure. See? Because space is full of stuff we don't see. So space doesn't really have any pressure. But the stuff in it does. The stuff we're not seeing. Stuff we're not paying any attention to.
It is inertia. When you talk about a ground, you need to ground the system. Now, there are different types of grounds. There are self-contained systems, like, say, a...
Now, it's always the same ground, actually. It's always an average. So, I mean, you know, yes, you can call it a ground when you're at 10 million megavolts, and you have a plus and minus relative to 10 million megavolts. So you go 10 million and 10, and then 900,000, whatever, blah, blah, blah. 9,999,900, well, whatever. And then, you know, but that ground would be impossible, so, you know, relative speaking, you couldn't have that ground anywhere near a real ground, because it would revert to the correct average. It would dissipate into, it would average out. It would become averaged. So I'm just saying the ground is seeking average.
A helicopter where the electrical system is grounded to the aluminum chassis, that's a different type of ground. But we're talking about signal grounding from antennas, or electrical grounding, or ground.
Well, no, you're saying you're talking about earth grounding. So that's, you're just searching for the word, but you're talking about an earth ground. Okay, so, yeah. So that's a really good average, because the earth is really heavy. So that's a good average amount of pressure.
An electrical circuit in general, that ground is counter space.
Okay, so he just pointed out how all of these things we call a ground can be different things. Okay, you could be grounded at at 200 volts. You could be grounded at minus 250 volts and call it a ground in an electric circuit. And now he's saying, but no, without saying the word earth ground, he's saying there's some other ground. Now, if he could have just said earth ground, and then everybody could say, okay, I get that. There could be perhaps a solar system ground, which would be another different potential. But it's still a vacillating potential. And there's still always a negative and a positive relative to it. So it can't be the pure form, because it's in the middle. Get it? So, yeah, I think you just don't understand Tesla. So this is Tesla's whole theory, was three-phase electricity. So, you know, this was Tesla's whole deal, was the idea of an arbitrary neutral, that would be your ground, and plus voltage and minus voltage. And when it's a wave, okay, what you're really saying is this goes from plus to the minus. And the ground would be this synthetic point that it never really stays at. So what you're doing is just having the two out of phase, and by putting them out of phase, okay, you always have from this wire to this wire the maximum potential, because this one's all the way plus, this one's all the way minus. So this would be your 240 volts in our system, and these voltages would be two separate or independent 120 volt circuits. Okay, and they would be, you know, in opposite phase. So you could take two of these 120 circuits and make 240 anytime you wanted to, because they were always out of phase, or you could just have the 120, and it's just that the voltage would be at any specific time moving one way in the wire, the ground, from one circuit, and moving the other way in the ground from the other circuit. You'd be pulling from ground in one circuit and pushing into ground in the other circuit. That's Tesla's contribution to mankind, and he doesn't seem to understand that. Funny.
You could actually say, well, to complete the electrical circuit, we need to make the connection to counter space.
No. So again, that's just so he thinks this is counter space, the ground, especially the Earth ground, and quite obviously, it's not counter space. You're pulling out of counter space or you're pushing into counter space, so it's clearly an average space. It's not the negativist space, and it's not the highest voltage pressure space. It's neither the lowest pressure or the highest pressure. It's an average pressure.
That actually is the ground. Where did you think it? What did you think a ground was in completing an electrical circuit?
Well, like I said, you ask that to Tesla, because he'll tell you something very different than what you just said. So we could go to Tesla's grave and try to awaken him for a few moments with some Greek waters of some kind, magic waters, counter space or something, and ask him the question. He'll say, "It's a fucking average, asshole. Not counter space."
How did you think that actually differentiated ground from counter space or counter space from ground?
How did I think it differentiated ground from counter space or counter space from ground? So again, counter space is anti-space. It's also space. It's also magnetism, force in motion, centrifugal divergence, ether, loss of inertia, and pure potential. When it seems clear that the potential is just a difference in pressure. See? The average pressure from the perspective of the low pressure is different. And the average pressure compared to the high pressure is different. So high to average and low to average are differences. See? Yes.
It's one and the same thing. This is how most of Tesla's inventions worked.
No. This is how, well, he didn't have any inventions, frankly. He really didn't. I mean, the Tesla coil, but that's just a coiled coil. I mean, let's see how to even say it. It's like putting an on-off switch on an already vibrating transformer. So you're already putting AC current into a transformer, and then you turn it on and off. Magnify the voltage that way.
It worked based upon the Earth capacitance. It was based upon using counter space to actually get out energy by using frequency and harmonics. So we can get into...
No, none of that happened. He actually used a capacitor, not the Earth's ground as a capacitor. So he had to actually make a capacitor, okay, to actually absorb voltage and release voltage. Because the ground wouldn't do it by itself. It had to force the ground to play along.
That discussion. It was a really deep discussion, but essentially, if, everybody throws around the term ground. A ground is counter.
I don't see where anybody's even throwing around even a little bit, but like I said, it's sort of understood that it's certainly not pure potential. Can't be that. It's not pure. It's the average.
Space. That is it. Well, it's lost. It's the completion of electrical circuit. We ground out a potential like a lightning grounding rod.
Yeah. Well, again, that's because of the differential. Now, you could have it go exactly the opposite way if you could find some way to synthetically create a huge, I think it's a negative voltage on the bottom of the clouds. Then you could create lightning again. It's just it would go the opposite direction.
Well, what do you think a grounding rod is? Is a little metal spike, whether it be copper or aluminum, sitting on the top of a...
Yeah, well, that is completely irrelevant, right? I mean, well, we know that the lightning rod is just a gimmick to get you being chosen for where the lightning lands. The lightning's going to land. It doesn't, you're not going to change that fact with your lightning rod. And you're just saying, hit the rod instead of hitting the building. You see, that's all. You're just trying to stick something up there that's more attractive to the potential difference. That creates more of a potential difference. See, thin little things on surfaces, little bumps on a surface even, little tiny bumps, will increase the voltage a little bit at those little points. So if you have like a 10 volts run through a wire, and there's little bumps on the wire, those little bumps might go up to 14 volts. So they're more likely to have interaction when there's enough of a potential difference with the rest of the world, because their voltage would be a little higher, their potential.
Tall apartment building where lightning is dissipated.
More pressure in the little bumps.
You're actually trying to ground an enormous amount of electrostatic energy in the case of lightning in counter space.
You're trying to ground it into counter space, and again, it's going to do that regardless, okay, because it's at a much higher pressure, and it just has to overcome the fact that it has to build a road, so to speak, a pipe to get here, because the atmosphere isn't conductive enough. It's not like a wire and it can just shoot down the wire, so it kind of has to make a wire out of little ions. It has to make a wire in the atmosphere to travel through. Yeah, whatever you say is silly.
A ground is counter space.
The ground is counter space. So I don't know what else to say. I mean, it really can't be. I don't think so. It's not anti-space, that's for sure. It's not force and motion, the ground. It's not centrifugal divergence. I don't see any of that going on.
Does it make it a little simpler?
No, it's stupid and silly. Who the hell watches this shit and says, oh yeah, that was so enlightening. I totally understand the whole universe now. Man, how far from making any sense was that? To go from nuclear bombs to ground and somehow tie those two things together. Like ground has potential. Oy. Oi. That's all I can say. Oi. Yeah, that was just terrible. So anyway, enough of a video. Till the next time he makes a silly video. At least for this series of videos. Yeah, there's just so much to do on this silly planet. So much silly to anti-silly and such. Counter-silly.